Good morning, my dear Prep 1 students. Hope you're all fine today. In today's lesson, we are going to have adding and subtracting of algebraic expressions. It's so easy lesson. It's typically just like adding and subtracting of terms. And if you get the idea of adding and subtracting of terms, you are going to do adding and subtracting of expressions so easy. So let's go first and remember how we used to add and subtract like terms. We said before that when we are doing addition or subtraction for terms, those terms must be like terms. So first of all, I know that I cannot do addition or subtraction except for like terms. So for example, if I have here 2x plus 4y, those two terms, they are unlike terms. And since they are unlike terms, I cannot add them or subtract them together. But we also took that when I have, for example, 2x plus 4x, here I have like terms. So, since I have like terms, I can add them and subtract them together. We also said that to say that two terms are like, I look for the variable. The variable in the two terms must be the same. And not only the variable, but also the power of the variable in both terms should be the same. So again, to say that two terms or more are like terms, they must have the same variable, and this variable is having the same powers in the two terms. So for example here, if I have 3x squared y and 5yx squared, here let's look. I have a variable called x squared, and here also I have a variable called x squared. And also, I have here a variable called y, and I have a variable here called y. So, both of them are having variables of x squared, of x, and x is to the power of 2, and both of them are having the variable of y, and y is to the power of 1. So yes, those two terms, they are like terms. So if I have like terms, simply I can add them together. If I said 3x squared y plus 5yx squared, I'm going first to look for the coefficient and add the coefficients together. So 3 plus 5, this is equals to 8. And what about the variables? The variables are written just as they are, x squared y. So when I'm adding or subtracting like terms, I'm only adding and subtracting the coefficient, but the variables remains as they are. What about, for example, if I told you that I want to add 9x squared y plus 7xy squared. Can I perform addition of those two terms? Let's go and have a look at the variables. I have here a variable of x, and I have here also a variable of x. But keep in mind that here that the variable x had the power of 2, and here the variable x is to the power of 1. So the variable x here is not like the variable x here. So I can say that those terms, they are unlike terms. And since they are unlike terms, I cannot add them or subtract them together. Is it clear now? So let's go now and see what about adding or subtracting of algebraic expressions. We said that we can only add and subtract like terms. So for example, here in question number 1, and this is the binder page 16, I want to find the sum of each of the following. Number 1, 5m squared plus 2lm added to l squared negative 3m squared negative 2lm. So here, the step that I'm going to use is that I'm going to write the first expression just as it is. And here is my first expression. So I'm going to write 5m squared plus 2lm. And then I want to add the second expression, which is l squared minus 3m squared minus 2lm to the first expression. As you can see here, I'm adding an expression to another. But we only said that we can add like terms or subtract like terms. So the only solution I have here is to arrange the second term under the first one, having all the like terms under each other's. So here, the first term I have in the first expression is 5m squared. 5m squared, so I'm going to look for a term which have also m squared. And the term here that have m squared is negative 3m squared. And we said before that we take any term with the sign before it. So here I'm having negative 3m squared. So simply I am going to write the first term as negative 3m squared to have all the like terms under each other's. And then the second term that I have here is 2lm. So I'm going to look also in the second expression for a term that have the variable lm. And here it is negative 2lm. Can I say 2lm? No, because the coefficient here of lm is negative 2. So it is negative 2lm. And we said before that we take any term with the sign before it. So here I'm going to write negative 2lm. As we can all see here, I have a term L squared, and L squared has no like term in the first expression. So simply I'm going to write it as it is. But the question here, is it a positive or a negative one? Since there is no operation before it or no sign before it, then it's a positive term. So I write plus L squared. Now, after I organize all the like terms under each other, it's easy for me to go and do the addition. And we said before that we only add the coefficient. So here I am going to add 5 plus negative 3, and 5 plus negative 3 is equals to positive 2. And what about the variable? I'm going to write the variable as it is. And here we are done with the first term. Let's go now and see the second term. 2 plus negative 2lm. So 2 plus negative 2, this is equal to 0. And 0 multiplied by any number, if I said 0 times lm, this is also going to equal 0. So those two terms, since they are the additive inverse of each other, they are cancelled together. I don't write anything in this term. Because simply, if I write here, for example, plus 0, 2m squared plus 0 is equal also to 2m squared. And that's why I don't write the plus 0. And as we all can see again, I have here a term that have nothing in the first term like. So exactly as if I'm saying 0 plus L squared. So this would be equal to positive L squared. So now my final answer for adding those two expressions is 2m squared plus L squared. And let's go now to see question number 2. Again, in question number 2, he wants me to have the sum of the expression 3a squared negative 2ab squared plus b to the power of 3 and a to the power of 3 plus 4a squared b minus negative b cubed. So again, we said that the first thing we do is to write the first expression as it is, and it is 3a squared negative 2ab squared plus b to the power of 3. And I'm going to see what I'm going to do with the second expression. Before we go and start solving the second expression, I want you to change the 3 to be 2. So this term is a to the power of 2. We are going now to arrange the like terms under each other. So the first term I have here in the first expression is 3a squared. I'm going to look for what else I have in the second expression having an a squared. So it's a squared. I'm going to write it as it is. And then I'm going to see in the second term here, I have negative 2ab to the power of 2. Do I have any term in the second expression here having the same variable, or it's like to negative 2ab squared? No, I don't have. So I am going to leave this space empty and then go and see what is the term that have b to the power of 3. And I will find that the term having b to the power of 3 is negative b to the power of 3. As we agreed, we take each term with the sign before it. So here it's negative b to the power of 3. Now we took a squared and we took negative b to the power of 3. Still we have positive 4a squared b. And since there is no any other term like it, so I'm going to write it alone at the end. Positive 4a squared b. And now it's easy for me after I arranged all the like terms under each other to go and have their sum. Now I am having 3a squared plus a squared, so we are going to add the coefficients. I have here the coefficient of 3, and I know that any variable written without a coefficient before it, this is 1. So 3 plus 1, this is equal to 4a squared. And since I have nothing here, so as if I'm saying negative 2 plus 0. So negative 2 plus 0, this is equals to negative 2 as well, and I'm going to write the variables as it is, ab squared. Let's go now and see what is the third term. The third term here I have positive b to the power of 3 plus negative b to the power of 3. Again, I have a term added to its additive inverse. And any term added to its additive inverse, it's cancelled together because it's going to give me 0. And the last one here is positive 4a squared b. Since I have no term written here, so as if I'm saying 0 plus 4a squared b, which is also going to equal positive 4a squared b. So at the end, after I take off the 0, my final answer is equal to 4a squared negative 2ab squared plus 4a squared b. And this is the last expression when I added the two expressions together. Let's have a look now at number 3. Number 3 I have 2a squared b minus 3ab squared plus b to the power of 3. So again, we said that the first step we do is to write the first expression as it is. I have here 2a squared b negative 3ab squared positive b to the power of 3. And I am going to add to it the second expression, which is negative a squared b plus b to the power of 3. Let's go and see the first term we have, and the first term we have here is 2a squared b. So let's go and see in the second expression what is the term we have that have a squared b, and we will find it here. It's negative a squared b. So I am going to write negative a squared b, and then the second term I have is negative 3ab squared. So again, let's go and see in the second expression, do I have any term containing ab squared? No, I don't have, so I'm going to leave this space empty. And then let's go and see, I have the term containing b to the power of 3. So going to the second expression and see, do I have anything that contains b to the power of 3? And yes, the term is positive b to the power of 3. So I'm going to write it as it is, as positive b to the power of 3. Now, after I arranged all the like terms under each other, it's easy for me to go and do my addition. I have here, we said that when I am adding like terms, I only go and add and subtract the coefficients. So here I have a coefficient of 2, so 2 plus negative 1. 2 plus negative 1 is equals to 1. And we know that when we have a coefficient of 1, we don't write it. So simply, I'm only going to write the variable as a squared b. And then I have here a coefficient of negative 3, and I've added to 0 since I have no term written here. So negative 3 plus 0, this is equal to negative 3. So my coefficient is negative 3, and what about the variables? They are just the same, ab squared. Going now for the third term, or adding the like terms together, I have b to the power of 3 plus b to the power of 3. So b here is to have a coefficient of 1, and b here also have a coefficient of 1. So 1 plus 1, this is equals to 2. So my coefficient here is 2, and the variable is as it is, as b to the power of 3. I hope it's clear now, prep 1. And let's go now and see more example in question number 4. In this question, I have 3 expressions that I want to add them together. I'm going to use the same way exactly. So as we agreed, let's go first and write the first expression as it is. It is 3x negative 4x squared plus 2. And I want to add to it the second expression, To add the second expression, first of all I must put the like terms under each other. The first term I have here is 3x, so I am looking for a term that also have x, and it is positive x. So I am going to write here x, and then let's go and see what is the expression that contains x squared. The expression here that contains x squared is x squared, and since there is no sign before it, so it is positive. So I have here positive x squared. And the last thing is an absolute term, and I have here an absolute term of negative 5. So I am going to write here negative 5. Don't forget, we have here 3 expressions, so I must go and arrange also the third expression. Again, I'm going to look for a term that have x. So here the term that have x is negative 4x. So I'm going to write here negative 4x. And then I'm going to go and see what are the terms that have x squared. And the terms here that have x squared is positive 3x squared. So I'm going to write here positive 3x squared. And the absolute term here I have is 3. And since 3 have no sign before it, so it is positive 3. So I'm going to write it here as plus 3. And now it's easy to find the sum of the 3 expressions together. We said before that to have a sum, we leave the variable as it is and we add the coefficient. So here I'm adding 3 plus 1 plus negative 4. 3 plus 1 plus negative 4, this is equals to 0. And let's go now and see what is the coefficient for the x squared. We said before that we take any term, we take the number with the sign before it. So I have here negative 4 plus 1 plus 3, and this is also going to give me 0. And what about the absolute term? It's 2 plus negative 5 plus 3, and this is also equal to 0. So at the end, when I add those 3 expressions together, my final answer is 0. Let's go now and have more example in question number 5. Again, I have here 3 expressions to add them together. So simply the first step I do is to write the first expression as it is. And then we are going to go and see the second expression and write the like terms under the first expression. So here I am looking first for an expression having x. The expression which have x here is negative 6x. So I am going to write negative 6x. And then I'm going to see what is the term that have x squared. And the term that have x squared here is 2x squared. And since 2x squared has no sign before it, so it is positive 2x squared. And I have here nothing in the second expression containing x to the power of 3, so simply I'm going to leave here a space. And then, as we all can see, I have here an absolute term. So I'm going to write the absolute term as it is plus 5. And then we are going now to see the third expression. And we are going to arrange it in the same way. I'm looking now for the term that have x. And the term that have x is positive 7x. So I'm going to write 7x. And then I'm going to see, do I have any term containing x squared in the third expression? No, I don't have any, so I'm going to leave a space. And now let's go for x to the power of 3. I have here a term called negative x to the power of 3, so I'm going to write negative x to the power of 3, and I have an absolute term of 4, and it's positive 4, so plus 4. Now it's easy to go and add the 3 expressions together, since I already arranged the like terms under each other. So to have the 3 expressions added together, it's 3 plus negative 6 plus 7, and this is equals to 4. So 4 is my new coefficient, and x, of course, the variable is written as it is. And by going now to see x squared, what's going to be the new term for x squared after I add the 2 together, I have negative 4 plus 2, and negative 4 plus 2 is equals to negative 2. And again, the variable is written as it is, as x squared. By having a look here, I will find that I have x to the power of 3 plus negative x to the power of 3. Again, this is a term added to its additive inverse. So they are cancelled together because they give me 0. And the last thing I have now is to add the absolute terms together, which is 5 plus 4, and this is equals to positive 9. And now I have added the three expressions together. And let's go and have the last addition in number 6. Now, I want to add three expressions together, and we agreed that the first step we should do is to write the first expression as it is. And then let's go for the second expression. The second expression is xy minus negative 2y squared plus x squared. The first term I have here is x squared, so I'm going to take the x squared from the second, which is positive x squared. So I'm going to write it as x squared. And then the second one is xy. So the term I'm looking for is xy. And here I have xy, and since there is no sign before it, so it's positive, so plus xy, and the term containing y squared here is negative 2y squared, so negative 2y squared. And let's go now and have a look at the third expression. The third expression contains only two terms, a term containing positive 3xy, so it's here positive 3xy, and the other term is negative 2x squared, so it is negative 2x squared. And since I have nothing here in the y squared, I'm going to leave it empty. And then now it's easy for me to go and add. I'm going now to add only the coefficients. I have 2 plus 1, negative 2, and this is equal to 1. And since 1 is not written as a coefficient, so I'm only going to write the variable, which is x squared. And let's go now and see. I have negative 3 plus 1 plus 3. Negative 3 plus 1 plus 3, this is also equal to 1. And again, we said that we don't write 1 as a coefficient, so it is positive xy. And the last thing is I have 1 plus negative 2. And 1 plus negative 2 is equals to negative 1. And since we don't write 1 as a coefficient, so this is equal to negative y squared. I hope it's clear now, prep 1, how can we add two or more expressions together. Let's go now, and I want to remind you with something before we go and see the subtraction. Do you remember when we said that when we were adding and subtracting terms, if I told you subtract a from b, this means that I'm doing b minus a, because I'm always taking from the bigger, and taking from b or subtracting from b, this means that it's the large one which I'm going to take from, so it is b minus a. And we also said that when I am told what is the increase of a then b, this means that I am asking a is more by how many? What is the increase of a? So a is more. So I am going to make a minus b. So again, when I'm told to subtract an expression from another one, so this means that I am doing the second expression minus the first one. And when I'm asked about what is the increase of an expression from a second one, this means that I am doing the first expression minus the second one. And those 2 points we are going to cover in today's video. Let's go now and solve examples on those 2 points. Again, to the binder page 16. Now, I'm asked to subtract 3x squared, negative 1, negative 5x from 1, negative 5x plus x to the power of 2. Again, we said that when I am set subtract a from b, this means I'm taking b minus a, so the second expression minus the first. So I am going to write here 1 minus 5x plus 6x squared. And I'm going to subtract from it the first expression, which is 3x squared, negative 1, negative 5x. But I'm going also to arrange it in the same way. So here, the first thing I begin with was the absolute term. So I'm going to see what is the absolute term in the first expression, and it's negative 1. So I'm going to write here negative 1. And then I'm going to go and see what is the term that contains x. The term that contains x here is negative 5x. So I'm going to write here negative 5x. And then I have the term that contains x squared, and here it is positive 3x squared. So I'm going to write here positive 3x squared. Until here is so easy, just like the addition. But now we want to take two steps which are very important. So after you arrange the terms to be subtracted from each other and write the like terms under each other, simply go and change this subtraction to be addition and change all the signs to their opposite. So here I have, instead of negative it's positive, instead of negative it's positive, instead of positive it's negative. And in order not to get confused, cancel the old signs. And then we are going to solve it as an easy addition problem. Just go and do 1 plus 1, and this is equals to 2. Negative 5 plus 5 and negative 5 plus 5 is equal to 0. So I'm not gonna write it. They are the additive inverse of each other. And then I go and do 6 minus 3, and 6 minus 3, this is equals to positive 3. So I'm going to write here positive 3, and of course the variable is as it is as x squared. So here, first of all, I must decide which term is bigger, which I'm going to take away from. After I arrange them, step number 1 I do is change subtraction to addition. And step number 2 I do is change all signs to their opposite. After I change all signs to opposite, number 3, cross all old signs. Why I'm crossing all the old signs? In order not to get confused. And let's go now and see number 2. In number 2, I want to subtract 3a b to the power of 2 negative 4a squared b minus b to the power of 3 from a to the power of 3 minus 2 ba squared plus 2b to the power of 3. Again, when I'm subtracting an expression from another, I am taking the second expression minus the first. So the first one I'm going to write is a to the power of 3 negative 2 ba squared plus 2b to the power of 3. And we said that we are going to subtract from it the second expression, and we are going to arrange the like terms under each other. Do I have anything here containing a to the power of 3? No, I don't have in the first term anything containing a to the power of 3. So I'm going to leave it empty. And then let's go and see what is the term that contains b a squared. So now 2b a squared is the same as negative 4a squared b. Both of them have the variable a to the power of 2 and the variable b to the power of 1. So I'm going to write here negative 4b a squared. And then I have negative b to the power of 3. But don't forget that I have here a term which is 3ab squared, which has no like term like it in the second expression. So I'm going to write it with its sign positive 3ab squared. Change the subtraction to addition. So here I'm going to change the subtraction to addition. And then change all the old signs to their opposite. So instead of the negative here I will have positive, instead of the negative here I will have positive, and instead of the positive here I will have negative. And in order not to get confused, don't forget to cancel all the old signs. And now it's easy to go and do it. I have a to the power of 3 plus 0, and this is equals to a to the power of 3. And then I have negative 2 plus 4, and negative 2 plus 4 is equals to positive 2, and of course the variable is as it is. Now I have 2 plus 1, which is equals to 3 as a coefficient, and my variable is as it is, as b to the power of 3. And I have here 0 minus 3, and 0 minus 3 is equal to negative 3, so my coefficient is negative 3, and the variable is as it is, as ab squared. Let's go now and see the second question. What is the increase of an expression from another? We said that when I am told what is the increase of an expression from another, I am taking the first expression minus the second expression. So now let's go and start writing the first expression, which is 2x squared minus 3x plus 1, and I'm going to subtract from it the second expression but arrange it the like terms under each other. So here I have 2x squared plus 5x minus 1. And the second step I'm going to do is change the subtraction to be addition and change all the signs to their opposite. I have here positive 2, so it is negative 2. I have here positive, so it is negative, and I have here negative, so it is positive. And don't forget to go and cancel all the old signs in order not to get confused. And now it's easy to go and have the sum of both of them. I have 2 plus negative 2, and 2 plus negative 2 is equal to 0. So those two terms will be cancelled together. And let's go now and see. I will have negative 3 plus negative 5. So negative 3 plus negative 5, this equals to negative 8. This is the coefficient, and the variable x is going to be as it is. And then let's go to the absolute term, which is I will have 1 plus 1, which is equals to positive 2. Again, let's go and see question number 2. What is the increase of 5y squared minus 3y plus 8, then negative 3y, positive 4, negative 2y squared? So again, we said that when I have to find the increase of one expression from another, this means that the first expression is greater. So I'm going to make the first expression, which is 5y squared negative 3y plus 8, and I'm going to subtract from it the second expression and arrange it in the same way. So the term having y squared is negative 2y squared, so I'm going to write here negative 2y squared, and the term having y is negative 3y, so I'm going to write here negative 3y, and the absolute term here is positive 4, so I'm going to write here positive 4. And don't forget, we said that when we are doing subtraction, we go and change the subtraction to be addition and change all the signs to their opposite. I have here negative, so it is positive. I have here negative, so it is positive. I have here positive, so it is negative. And don't forget to go and cancel all the old signs in order not to get confused. And now it's easy to find the answer. Simply, I'm going to do 5 plus 2, which is equals to 7. The coefficient is 7 and the variable is y squared as it is. Negative 3 plus 3 and negative 3 plus 3, this is equals to 0. So those two terms are cancelled together, and I'm not going to write anything here. And at the end I have 8 minus 4, and 8 minus 4, this is equals to positive 4. So again, when we are doing subtraction, just follow those 3 steps. After we write the two expressions under each other, change the subtraction to be addition, and then change all signs to their opposite. If you have positive, make it a negative, and if you have negative, make it a positive. And don't forget to cross all the old signs in order not to get confused, and then do it as an addition problem. I hope it's clear now. Prep 1, it's so easy, just need some practice. I would like to thank you all, Prep 1, and have a nice day.